What's up everyone, Patrick here, welcome back. Moving on to the next example, we have to solve these systems here by elimination. So notice that all of these are in fractions, so getting a little practice with some algebra here. So starting with number one, we got 1 over 3x plus y is equal to negative 3, and then we got 1 over 2x minus 2y is equal to negative 1. Now, a couple of different ways to go about this. The first thing that I like to do is get rid of any fractions. Okay, you don't necessarily have to though. So with this first one, I'll show you two different ways to do it with the first one, but then these last two, I'm going to do it in one way where I'm just getting rid of the fractions. But this one is actually not too bad the way it's set up to work with fractions. Now, actually, before doing that, what I like to do personally is I actually like to combine these. So 1 over 3x, that's the same as x over 3. And then we'll have plus y. Then the y I'm going to put over 1, and then the negative 3. I'll put over 1 like that. Just feel like it's a cleaner way to look at it. And this is actually, instead of having 1 over 3x, you may get questions that are in this format, right? X over 3, 1 over 3x, both of those are the exact same thing. So same thing over here, this 1 over 2x, I'm going to change to x over 2. And then we have this 2y, which I'm going to put over 1. And then I'm going to put the negative 1 over 1. The reason why I'm putting everything, any non-fraction expressions over 1, is because to multiply these, you got to multiply them by the lowest common denominator. And so it's just easy to see here, 3, 1, 1. What's the lowest common denominator between these? Well, it's going to be 3. So I'll multiply this by 3, multiply this by 3, multiply this by 3. Okay, so what we would end up with is these 3's cancel out, so we'd have x plus y over 1 times 3 is 3y, and then negative 3 times 3 is negative 9. Right, so this and this are the exact same thing. It's just now we don't have any fractions to work with. Here, lowest common denominator between 2, 1, and 1, it's 2. So I'm going to multiply this by 2, multiply this by 2, multiply that by 2. You got to multiply all the expressions by the same value on the left side and the right side. So the 2's cancel out here. We'd end up with x minus 4y is equal to negative 2, like that. And then from here, notice the x's are the same. We could just subtract this from that. We don't actually even have to multiply anything. So subtracting everything here, x minus x is 0. 3y minus negative 4y is like 3y plus 4y, which would give us 7y over here, right? So be careful when you're subtracting. You got to distribute that negative to everything. And then we have the negative 9 minus the negative 2, which would be negative 9 plus 2, right? Which would be negative 7. So just be careful with this. That's a common way to slip up when you have these negatives here. Okay, maybe do some work on the side just to make sure you're doing it correctly. So from here, we could divide by 7. We could divide by 7, so y would end up equaling negative 1. And then if we want to get the corresponding x value, I'm going to plug it into one of these. So I'll plug it into the first one. So we'll have x plus 3 times the y value of negative 1 is equal to negative 9. X minus 3, rather, is equal to negative 9. So x is equal to negative 9 plus 3. X would be negative 6. So negative 6, negative 1 is the point of intersection between those lines. Okay, so that's one way to do it. And we're also going to do a check on these after I show you the second way. Now, if you don't want to get rid of fractions, for these questions, this one maybe isn't as big of a deal, but for something like this, you definitely want to. Right? It's just going to save you a lot of headache. It's just tough to see how to do elimination, what to do elimination on in this kind of format. Okay, but if you wanted to work with fractions here, what you can do is, notice we have a negative 2y, and then we have a 1y. So let's get this to be 2. So we can multiply everything by 2, multiply this by 2, multiply that by 2. And so what we would end up with is 2 over 3x plus 2y is equal to negative 6. And then we'll have 1 over 2x minus 2y is equal to negative 1. Right? That second equation we're keeping the same. The reason why I multiplied by 2 is because now, right, we could just add these. Because they're opposite signs, we can add them to get rid of the y values. So adding these, 0. What's 2 over 3 plus 1 over 2? Multiply this by 2, this by 2, this by 3, this by 3. Lowest common denominator is 6, right? So we'll have 4 over 6 plus 3 over 6, which would give us 7 over 6. So we'd end up with 7 over 6x equals this plus this. Negative 6 plus negative 1 would give us negative 7, like that. All right, and then from here, to get this x by itself, we can, actually there's 2 ways to go about it. So let me show you. 7 over 6x is negative 7. So we could divide both sides by 7 over 6. Right, to get the x by itself. So we'd end up with negative 7 over 1 divided by 7 over 6. Whenever I have something like this, I like to convert it into that format. So it would be negative 7 over 1 times 6 over 7. The 7's cancel out. We end up with negative 6, which is what we got the last time. Another way to do this is to combine these like I did before. So we could rewrite this as 7x over 6 is equal to negative 7. This would be like over 1. And so instead of doing this division of fractions here, you can just cross multiply. Right? So that's another way, if you feel more comfortable getting the value like that. Right? So whichever way you do it, x value is negative 6, and then the y value is negative 1. If we took this negative 6 and plugged it into here or here, solve for the corresponding y value, you would get a y value of negative 1. Right, so this is an example. If you do want to work with fractions, you can go about it that way. Personally, what I do is I get rid of the fractions, turn everything to be integer coefficients, and then from there, I do substitution or elimination. In this case, we're just working with elimination. Now, what if we do a check on this solution? So we'd have 1 over 3 times negative 6 plus y, which would be negative 1, and that should be negative 3, right? Ignore these 2's that we multiplied before. We're just looking at the original equation. So 1 over 3 times negative 6 would give us negative 2, plus negative 1 is like minus 1. Negative 3 is equal to negative 3. Right, so the first check, all good. And then we have, for the second equation, 1 over 2 times the x value of negative 6 minus 2 times the y value of negative 1. That should be negative 1. Let's see if it is. 1 over 2 times negative 6 is negative 3. Negative 2 times negative 1 is positive 2. And so we'd end up with negative 1 equaling negative 1. Right, so we can be pretty confident that that solution is correct. Now moving on to number 2, so we got 3 over 5x minus 1 over 3y is equal to 2, and then 5 over 4x minus y is equal to 13 over 4. So as I did in number 1, what I'm first going to do is convert these to be a nicer format. So this 3 over 5x, I'm going to combine that to be 3x over 5, minus 1 over 3y, that's going to be y over 3, and then the 2, I'm going to put over 1. Again, you don't necessarily have to do this, but this is what I personally do in order to minimize mistakes. There's just, I don't know, this is just there's just less going on here, right? And it's clear to see here, there's like expressions mixed versus this is like one expression, one expression, one expression. So doing the same thing over here, we'll have 5x over 4 minus y is by itself, so that's over 1, and then we have 13 over 4. So that is the second equation. And from here, what I'm going to do is get rid of the fractions. So we want to multiply everything by the lowest common denominator between 5, 3, and 1. What is it? 15. So I'm going to multiply this by 15. I'm going to multiply this by 15. I'm going to multiply this by 15. Okay, now be careful with the algebra here. Notice 5 goes into 15 3 times. 3 goes into 15 5 times. And then this is like 2 over 1, which is 2 just multiplied by 15, which is just 30. So we cross these out, but we have a 3 left here. So we have 3 times 3x, which would give us 9x, minus this crossed out, but we have a 5. 5 times y is 5y. And then 15 times 2 is just 30. So this original and this, they're the exact same thing, right? They look totally different, but they are actually the same equations. All right, and then doing same process for the next one, 4, 1, and 4, it's just 4, the lowest common denominator. And this one's nice. These just cancel out, so there's nothing left here that we have to worry about like we had over here. So we'd end up with just 5x minus 4y is equal to 13. Okay, so this and this are the exact same thing. Okay, so because this and this are the same, then the solution to this linear system is going to be the same as the solution to that linear system, and we will do a check at the end as well. So solving this by elimination, let's get rid of the y values. So I'm going to multiply this by 4, and then I'll multiply this by 5. Right, so to get negative 20y and then negative 20y, and then we can subtract them. And actually, you know what? Let's switch it up in this case. Let's multiply everything. That's one way you could do it. I'm going to actually multiply everything by negative 4 here. In order to get positive 20y here, and then this would be still negative 20y, and then we don't have to worry about subtracting them. We could just add them, right? Because with the subtracting, then you have to worry about negatives and whatnot. Actually, in this case, you wouldn't even worry about the negatives. There wouldn't be any negative values. But anyway, I'm just going to switch it up in this case. You don't necessarily have to do this. You also don't necessarily have to get rid of the y values. You could get rid of the x values. You'd multiply this by 5, multiply that by 9. So whichever way you go about it, just make sure you're getting the same solution. So if I multiply everything by negative 4, I'll have negative 36x plus 20y is equal to negative 120. And then multiplying these, I'll have 25x minus 20y is equal to 65. And actually, maybe that wasn't the best move, because now we actually are dealing with negatives. I just personally like adding, right, to get rid of stuff in elimination versus subtracting. But yeah, maybe this move made it a little bit more complex, but let's work with it either way. So this plus that, 0. This plus that would give us negative 11x. And then negative 120 plus 65 would give us what? Negative 55. Divide both sides by negative 11. Divide this by negative 11. X would end up equaling 5. Okay, I actually do feel like I owe you guys just to see what would happen if we kept it positive. This would be negative. This would be positive, right? And then what would happen is that these now would be the same sign, so we could subtract this from that. So 36x minus 25x would actually be smoother. In this case, this minus that would be 55. The reason I usually don't like subtracting is because sometimes there's negatives, and then you just gotta, there's just more to think about. and stuff. But in this case, there actually wasn't any negatives. So this way was probably easier. Everything lined up really nicely. So whichever way you do it, the x value is 5. Now to solve for the corresponding y value, you could plug it into any of these equations. I'm going to plug it into this one, so we'll have 5 times 5 minus 4y is equal to 13. 25 minus 4y is equal to 13. Let's bring the negative 4y over. Let's bring the 13 over. 25 minus 13, 12. 4y, divide both sides by 4. Y is equal to 3. Right, so that ends up being the final solution. So whichever way you go about it, just make sure you're getting that solution. All right, so between these two lines, point of intersection is 5 and 3. Now, let's do a check on this, and let's make sure left side is equal to the right side. So starting with the first one, we got 3 over 5 times 5 minus 1 over 3 times the y value of 3, which is equal to 2. These 5's cancel out, these 3's cancel out, so it's pretty nice. 3 minus 1, 2 is equal to 2. So that's all good. Then we got 5 over 4 times the x value of 5 minus the y value of 3. That should be 13 over 4. So this one's going to be a little bit more complex. This 5 is like over 1. Multiplying these would be 25 over 4 minus 3 over 1. To get a common denominator on the left side, multiplied by 4, multiplied by 4. 25 over 4 minus 12 over 4 does indeed give us 13 over 4. So left side is equal to the right side. Okay, so we could be pretty confident that that is the correct solution. That's the point of intersection between these two lines. Now finally moving on to number 3. So we got x minus 3 over 2 plus y plus 1 over 5 is equal to negative 2. And then we have x plus 1 over 2 minus y plus 2 over 3 is equal to negative 3. So in this case, same thing. I'm going to get rid of the fractions. There's more going on than in the numerators here, but the same process is going to apply. Actually, one thing I want to mention, another format something like this could be in is 1/2 x minus 3. Right? Or maybe this would be like 1 over 5 y plus 1. Okay, so maybe you'll see something like that. Okay, this and this, they're the exact same thing. And kind of like in the previous ones, if I see something like this where these are separated, I like to put them together in order to be in that nice format. So it's actually already given in that nice format. But if you do get something like this, then I recommend taking this, converting it to that, and then following the steps that we're about to do. Sometimes this won't be a 1, there might be like a 2 over here. So if that's the case and you combine these, it would end up equaling 2 bracket y plus 1 over 5. Or if you want to even distribute the 2, you can do that. You could do that as well. So you'd have 2y plus 2 over 5. All right. So something like this, just convert it to be in that format. But it's already in that nice format. These negative 2, negative 3, I'll put over 1. So we'll have negative 2 over 1, negative 3 over 1. And same formats or same process. So 2, 5, 1. What's the lowest common denominator between these? It is 10. So I'm going to multiply this by 10. Actually, let's put the 10 in front. I'll show you why in a sec. 10, 10. So from here, 2 goes into 10 5 times, 5 goes into 10 twice, and then 1 goes into 10 just 10 times, right? If you get the right common denominator that you're multiplying, there should be no denominators left, right? The reason why we're multiplying by the lowest common denominator is to get rid of the denominators, to get rid of the fractions. But you got to be careful here. You end up with a 5, and it's going to be 5 bracket x minus 3. That's why I wanted to put that 10 in front there. Then over here, there's a 2 left, and it's multiplying by that whole expression. So you got to put these expressions in brackets over here. And then 10 times negative 2 is just negative 20, like that. Okay, if we follow the same process here, 2, 3, 1, 6, lowest common denominator, multiply by 6, multiply by 6, multiply by 6. 2 goes into 6 3 times, 3 goes into 6 twice, 1 goes into 6 just 6 times. So we'd end up with 3 bracket x plus 1 minus 2 bracket y plus 2, yep, equals negative 18. All right, so still a fairly complex format, but no fractions to work with. We're just going to have to distribute all this, simplify it, but nevertheless, we did get rid of all the fractions, and personally, I'd rather work with this versus working with something like that. Another thing I want to mention is another thing you might see done. I would not recommend going this way, but it might be something that you may see your textbook maybe do, is they'll split up the fractions from here. Okay, so they'll change this to be x over 2 minus 3 over 2 plus y over 5 plus 1 over 5, which is equal to negative 2, like that. And then you could just multiply by the lowest common denominator of all these, which would still be 10. And that may not be actually the worst thing in the world either, because then you're not going to have to worry about distributing, right? Because if I distribute in this one, notice that I'll have 5x minus 15 plus 2y plus 2 is equal to negative 20. Well, if I multiply everything by 10 over here, this by 10, this by 10, this by 10, this by 10, and this by 10, watch what happens. 2 goes into 10 5 times, 2 goes into 10 5 times, 5 goes into 10 twice, 5 goes into 10 twice. So we'd end up with 5x, 5 times 3. Space these out so it's not too jumbled up like this. Oh, multiplied. We also have to multiply that by 10, so that would be negative 20, like that. And then notice this, they're the exact same thing. Okay, so that's another way to potentially go about it. It's just you're going to have to multiply. It just gets maybe a little bit more messy. You're going to have to multiply the 10 multiple times. Be careful with your signs. There's a negative here, right? But you end up in the same place. So that's another way you may see a textbook or a teacher may go about it. And actually, another thing you could do is that before multiplying everything, you can simplify the numbers. So notice this is a number, that's a number, that's a number, right? So simplify those to be one fraction and then multiply everything so you wouldn't have these numbers here. It's just I feel like doing that algebra would increase the chances of making a mistake versus just getting rid of all the fractions at that point. Okay, so again, multiple ways to go about this. Just whichever way you're doing it, make sure you're getting the correct solutions consistently with these questions. So from here, we got to simplify this second equation. So we'll have 3x plus 3 minus 2y minus 4 equals negative 18, right? When we distribute everything, yeah, everything's all good. So what I'm going to do now is collect all the like terms. So this first equation, I'm going to keep the 5x and the 2y on the left side. So we'll have 5x plus 2y is equal to negative 20. Then I'm going to bring the negative 15 and the positive 2 over. So we'd have positive 15 minus 2. So that would simplify to negative 7. Negative 20 plus 15 is negative 5. Minus 2 is negative 7. Okay, so this original equation that we had and this are the exact same thing, just different formats, and that's just a much nicer format. And then with this second one, the 3x Let's do it at the bottom here. So we'll have 3x minus 2y. Positive 3, negative 4, I'm going to bring over. So I'll have negative 18 minus 3 plus 4. Okay, when you're doing this algebra, just be very careful, right? Very diligent. Check your steps each way. Checking steps, even though it takes a little bit of time, it does save time in the end, always. It's always a good investment to do. So 3x minus 2y, negative 21 plus 4 would give us negative 17, right? Okay, so this original equation that we had and this are the exact same thing. And so now what we can do is we can just make it that equation, 5x plus 2y is equal to negative 7, and then 3x minus 2y is equal to negative 17. And we just work the elimination on this, and actually it's nice. These are already, we have 2y, negative 2y, we could just add these, right? 0, 8x, negative 7 plus negative 17 is like negative 7 minus 17, which would give us negative 24 divided by 8. X is equal to negative 3. And then we could take that x value, we could plug it into either of these. I'll plug it into the, let's plug it into the first. The y value is already positive there, so we'll have negative 15 plus 2y is equal to negative 7. Bring this over. 2y is equal to negative 7 plus 15, which would give us 8. Divided by 2. Y is 4. So negative 3, let's write this over here. Negative 3 and 4 is the solution. So that's going to be the point of intersection between those two lines. And now if we want to do a check, so negative 3 and then 4, let's plug them into the originals. Let me actually rewrite the originals just because there was a lot going on there. Okay, so and then we have x plus 1 over 2 minus y plus 2 over 3, and that was negative 3. Right, so those are the original equations. So to do a check, we just plug in for the x and y values, see if the left side is equal to the right side. So starting with this one, we'll have negative 3 minus 3 over 2 plus y, which is 4, plus 1 over 5. That should give us negative 2. Let's see if it does. So we'd end up with negative 6 over 2 plus 5 over 5. Negative 3 plus 1, negative 2 is equal to negative 2. So that's nice, right? So the first equation, all good. Let's try it with the second equation. X plus 1 over 2, so we got negative 3 plus 1 over 2, right? Minus y plus 2, so 4 plus 2 over 3. Let's see if it equals negative 3. This would be negative 2 over 2 minus 6 over 3. Negative 1 minus 2. Negative 3 is equal to negative 3. All right, left side is equal to the right side. So the check works out with both equations. We could be pretty confident that that's the correct answer.